Imagine setting out on the longest journey humanity has ever considered, a mission to Alpha Centauri, our nearest star system, over 4 light-years away. It's a trip so vast that, with today's technology, it would take over 6,000 years. But what if we had the tools and technology to make it in just a lifetime? How would we survive such a journey? Let's dive in. First, let's tackle the basics. The primary challenge? Distance and time. Alpha Centauri is about 4.37 light-years from Earth. If we could somehow travel at 10% the speed of light, roughly 67 million miles per hour, it would still take over 40 years to reach our destination. 40 years may sound long, but it's feasible in a human lifetime, especially with a multi-generational crew. But survival on this journey brings some unique challenges. To make it through decades in space, our first major requirement is sustainable life support. This means recycling air, water, and even food. Advanced hydroponic systems could grow food on board, while oxygen scrubbers recycle and clean the air. Everything has to be reused. Waste? It would be processed and repurposed as fertilizer for crops or recycled into building materials. Next, there's the question of power. Solar energy won't work so far from our sun, so we'd need a reliable, long-lasting energy source. Advanced nuclear fusion or fission reactors are the most likely options for a journey of this length, providing continuous power for decades to run life support systems, propulsion, and communication. But surviving isn't just about keeping the body alive. The mind needs to stay healthy too. Living in close quarters, surrounded by the same people, could lead to stress, isolation, and even depression. One solution? Virtual reality. With VR, crew members could visit Earth, explore simulated environments, and even engage in games or social activities. Plus, regular schedules with structured social and alone time would help maintain mental health over the long haul. Keeping the crew physically healthy would also be a challenge. Decades without gravity could weaken muscles and bones, so we'd need either artificial gravity or rigorous exercise routines. Another concept being studied is cryosleep, where crew members would spend much of the journey in suspended animation. Cryosleep would drastically reduce resources needed for food and water, while also reducing the psychological strain of the journey. While not yet a reality, cryosleep is one of the most promising areas of research for future deep space travel. And then there's radiation. Space is filled with dangerous cosmic rays and solar radiation, and after a few decades, this could be deadly. To protect the crew, the spacecraft could be shielded with thick materials like water or even magnetic fields, which would deflect harmful particles, much like Earth's magnetic field protects us. Communication is another unique challenge. With Alpha Centauri over 4 light-years away, even messages traveling at the speed of light would take over 4 years to reach Earth, and another 4 years to get a reply. This delay means the crew would be largely autonomous, relying on pre-installed systems and AI to manage unforeseen issues. So, could we actually make it to Alpha Centauri? The answer is yes, but it will require major advancements in technology, sustainability, and understanding of human psychology. While the journey would be dangerous, it's a real possibility that in our lifetime, the first interstellar explorers could set out on this incredible adventure. If you enjoyed this video, like, subscribe, and hit that notification bell. Let us know in the comments if you think a journey like this would work in the future, but in the meantime, stay looking up.